Hey guys, how's it going? This is Pat Neppy here from PNLearning.net, and this is another video in my series that I'm doing on the SAT practice test number 2. We're going to be going over a question from the part 3 today, and that is the no calculator section. So put your calculators away if you've got them. We're not going to need them for this one. And today we're doing number 18, and we've got a nice little geometry question. Here we go. So we've got two triangles here, and we might off the bat notice that we've got some measurements for the lengths of sides, and we might also take note that we've got some vertical angles here. And it says, in the figure above, AE is parallel to CD, and segment AD intersects segment CE at B. What is the length of segment CE? Okay, so we've got what I like to call an hourglass situation, right? If you have an hourglass sort of figure, and the hourglass is kind of dependent on one thing, right? An hourglass is going to have this bottom edge and top edge being parallel. And that's exactly what we have here. Anytime you get an hourglass like that and you know that you've got parallel top and bottom edges, you're going to have two triangles that are proportional to one another, meaning that one is an exact multiple of the other, whether they're roughly the same size like this, or whether maybe you have one on top that's a lot smaller or one on the bottom that's a lot smaller. Whatever the case may be, as long as these edges on the top and bottom are parallel, you're guaranteed to get these proportional triangles. Anyone who's taken geometry would have gone through proofs that involve figures like this, so it's not completely unfamiliar. So one thing that's not completely obvious about this hourglass scenario is which sides are going to correspond to which other sides. This side here, which is 5, is going to correspond to this side, which is 10. And this side, CB, is going to correspond to this side, which is 8. And that's not totally obvious. You might think that it's more like CB and AB correspond, or that DB and BE correspond. And that would be a mistake. So why is that? One of the ways I could explain this is by sort of taking this diagram and breaking it down with angles. Like, for example, we know in an hourglass situation that these two angles have to be congruent. These are going to be what we call vertical angles. And if we know that the top and bottom edges are parallel, we're actually going to be able to think of them as parallel lines. And what we can get here are sort of opposite interior angles. If you remember from geometry, opposite interior angles would be any two angles that are on opposite sides of what we call a transversal. This side of the hourglass, we could call this the transversal. And if you have two angles that are on opposite sides of the transversal and against the parallel lines, we call them alternate interior angles, right? They're interior because they are sort of within the parallel lines. And so the angles which are opposite interior have to be congruent. That would mean these two purple angles, and also, let's say, I'll just use red here, these two angles. Those are going to have to be congruent. So the reason why we have a situation where the correspondence of the sides does not work, sort of like left side with left side and right side with right side, that situation pops up because if you look at the angles, we know that two triangles are going to have corresponding sides according to what angle they are opposite. So opposite the red angle would be this side, and opposite the other red angle would be this side. And that's why we sort of have a crisscrossing of which sides of the triangle are going to correspond. Across from the purple angles, we have this side, and across from this purple angle, we have this side. And of course, that means that the sort of top and the bottom sides correspond as well. So a lot going on there. I'm just kind of reviewing some stuff here from geometry, but that is why in this problem, it's important to know that CB is going to actually correspond to BE, and DB is going to actually correspond to AB. So now that we figured out which sides correspond to which other sides, we just have to figure out how many times bigger one triangle is than the other. If we look at these two corresponding sides, right, 10 and 5, we have a sort of times 2 or divide by 2 relationship. That means the bottom triangle is twice as big as the one up top. And if we just sort of extend that to the other sides of the triangle, we could assume that 8 is twice as big as this side here, CB, and that would mean that CB has to be 4. So now that we have CB and BE, we can find the total length of the line segment that they want, which is CE. So all we have to do is add 8 and 4. And it doesn't get much easier than that, folks. Just simple addition. 8 plus 4 is 12. We've got our answer. So that's it for number 18. As long as you know a little bit of geometry, that one should be an easy one for you. You just kind of have to divide by 2 and then add those sides together. A longer way to do the problem would be to set up a proportion, but for those of you who have done this type of question before, sometimes the numbers are friendly like they are in this case, and you really don't even have to do that, right? You can just say, hey, the top one is half of the bottom one, and just be done with it. If you can think of a quicker or better way to go through this problem, definitely leave me a comment. And if you found this video helpful, definitely give it a like, subscribe to my channel, or maybe share this video with someone else you know who's going through SAT prep and having trouble with the math. I do offer one-on-one SAT prep and group SAT prep at my website, PNLearning.net. I will leave a link in the description, so definitely find your way over there. I offer some of the cheapest SAT prep available. Most places that you'll find charge anywhere between $100, $200, $300 an hour for SAT prep. But if you join one of my group courses, you can actually get it for $33 an hour. And that includes 12 hours of instruction over 6 weeks leading directly up into your SAT. And really, there's no better value out there. So definitely check out my website if you think you might be interested in that. That's it for number 18. Thank you guys for watching, and I'll see you for the next video.